All right, hello Algebra 2. This is lesson 3.1, graphing linear systems. So we are solving a system of equation, and a system of equations is where we have more than one. So there are two or more equations. And for us, we're just going to focus on two equations, and we are looking for where the equations intersect. So the solution is the x, y ordered pair where the lines intersect. All right, and so that's what we're looking for today. We're looking for where the lines intersect. This is a great IXL assignment for graphing. It is really going to make sure that you know how to graph lines, and it's quite good. So we want to graph the system, and I'm also going to show you how to check your solution. And I want you to focus on checking because on this Unit 3 test, this is a fantastic test for you to be able to get 100% on it. If you know how to check an answer, then you can get 100% on your test. As simple as that. So first of all, when we're graphing the system, we want to make sure that we're in y equals mx plus b form or slope-intercept form. All right, and so if we're in slope-intercept form, then graphing is going to be super easy. And you can see here, this is y equals mx plus b. So this is in a great form. The y is already by itself, and I'm going to go ahead and graph it. So you're going to see a really nice graph just like this on IXL. And what you need to do is you have to scroll down, and underneath at the bottom of the graph, there'll be colored equations, and you need to click on the color to make sure that you're graphing the proper line. So you're going to click the colored box. One is going to be blue and one will be green, or what other combination of colors it is. So this has a y-intercept at 5. So we begin at 5 on the y-axis. So you're going to then click your y-intercept, and then you're going to also then count the slope. And the slope in this case is the number in front of x. So that means down 2 over 1, down 2, right 1. So I'm going to move down 2 and then right 1 and make another click. And you'll see the magical line appear. It's very cool, and I cannot do that here. I'm going to go ahead and sort of click a few more points just so I make sure that my line crosses nicely on my graph here. You do want to make these graphs, but you don't have to make them super wonderful. Just make sure you count that slope. The nice thing about IXL is it will graph a perfect line. So then after you graph your first line, you're going to want to click the second equation. So it's graphing the second line. And again, here is our beginning point here. We're going to start at -2 on the y-intercept. So on the y-axis, we're going to put a click and put a point there at -2. And then on this one, the slope is 3 over 2. And that's telling me to go up 3 and right 2. So from this point, we're going to count up 1, up 2, up 3, and right 2. And then once you click, your beautiful line will appear on IXL. It's very cool. I'm very impressed. And then it's going to ask you to type in the solution. So the solution is this point right here where the lines intersect, and that ordered pair is 2, 1. And so you'd have to type in the intersection point, and then it'll tell you did a great job. I want to show you how to check. So to check, you need to check both equations. And this is a solution for x and a solution for y. It's an x-y ordered pair. And so x being the horizontal axis, okay, which means if we want to check, we get to plug in the x and the y value in each equation. So I'm going to check my purple equation right here. I'm going to plug in the 1 for the y, and then -2, and in place of the x, I'm going to plug in my 2. And we're just checking for balance. Here we'd have -4 plus 5. And that is correct. -4 plus 5 is 1, and we have balance. So anytime you're checking, that's what we're looking for. Now, it's not good enough to just check one equation. You also want to check the second equation as well. So again, in place of y, we're plugging in 1. 3 halves times, in place of the x, a 2, and then minus 2. So again, I can multiply 3 over 2 times 2. The 2's reduce, and I just get 3. And then 3 minus 2 is 1. So we have balance. And so we know that we did it right. Okay, so this solution checks perfectly. And this is a great solution for if you're given a graph, is this a solution? Or if they say, is this a solution? Then all you need to do is plug in the x and plug in the y value to both equations. So you do need to check both. And again, do you have to do this on your homework? No. Do you want to do it on a test? Yes. I definitely recommend doing a little bit of practice with it. All right, over here, whoops. This equation is not in slope-intercept form. So I'm going to take this equation, and we need to isolate y. And so that it's in slope-intercept form. So to isolate y, the first thing I'm going to do is subtract x from both sides. So we get -2y equals, now these are not like terms, so I'm going to put the negative x and then the positive 4, and they're just going to take up space next to one another. And then I'm going to divide everything by -2. And we get y equals, negative divided by negative is positive. And you should also realize that there's a 1 always, always in front of that x. And that's really helpful because now you see that we have a fraction 1/2. So positive 1/2 x, 4 divided by -2 is -2. So you would want to solve for y and then click your equation, and then we can graph it. So the y-intercept is -2. Again, that's on the y-axis. So we click on -2, and then the slope is 1 over 2, or up 1 and right 2. So we're going to go up 1 and right 2. And when you click, you'll get a lovely line. Any 2 points are going to give you a beautiful line. You do want to make sure that your slope is correct. So same thing on this second equation. We have x plus y equals 4, and we need to get the y by itself. Same thing. So I'm going to move this x to the other side, so I'm going to subtract x. So I have y equals, again, these are not like terms, -x plus 4. So this is a great equation. The y is by itself. Also, this is a negative, but remember, there's always that little invisible 1 there. So it's a -1. So you would click your second equation box there, and then we can plot the y-intercept of 4, and then count the slope. And in this case, the slope is -1. Turn it into a fraction by putting it over 1. So this tells me to go down 1 and right 1. So I'm going to go down 1 and right 1. And once you click 2 points, then your beautiful line will appear. And to get rid of the line, if you make a mistake, you just click those points again and the line will disappear. You can see the intersection here is the solution. That solution in this case is 4 for the x value and 0 for the y. So 4 for the x value, 0 for the y, and I'm going to check that really fast. And this is totally something you could do in your head as well. So the x value is 4, minus 2 times 0 equals 4. Yes, that's absolutely a true statement. 2 times 0 is 0. 4 definitely equals 4. I'm going to check the second equation. 4 plus nothing equals 4. Yes, that is also true. So it's usually pretty easy to check. All right. Once again, I'm going to go ahead. These are not in slope-intercept form, so I want to isolate the y. If it isn't isolated, that's a great way to graph. So I need to take this x term and move it over here. So I'm going to subtract 2x. So I have 3y equals, again, these are not like terms, so we're just going to set them next to each other, taking up space. And then divide every term by 3. So we get y equals, this is negative 2/3 with an x, and negative 3 divided by 3 is 1, or negative 1. So once you get y by itself, then we can graph it. So you're going to click your equation that you're trying to graph, and then we can plot our y-intercept at negative 1. I'm going to write that down. That is the y-intercept. Y-intercept at negative 1, and then our slope is negative 2/3, and that's telling me to go down 2 and right 3. The top number tells you to go up or down. So this is negative, it's telling me to go down. The bottom number always to the right. Okay. So we're going to go down 2 and right 1, 2, 3. All right. So once you click 2 points on IXL, then you'll get this great line. Super cool. All right, I'm going to go ahead and work the second equation. 3x plus y equals 6. Again, I need to isolate y. So I need to move this 3x term over. So I'm going to subtract it. Do the opposite. So that becomes negative 3x, and this is a positive 6. And the y doesn't have a number in front, doesn't have a coefficient in front, so it's set to go. For graphing, it has a y-intercept of 6. So click your equation and click your y-intercept, and then the slope on this one is negative 3. I'm going to turn it into a fraction by putting it over 1, and then that tells me to go down 3 and right 1. So from my y-intercept, I'm going to go down 1, 2, 3, and right 1. All right, and once you click twice, the line will appear. I wanted to be very careful when I'm graphing by hand. And we see the point of intersection is right here, and that solution is 3 on the x-axis and negative 3 on the y-axis. And so all this is something you'll have to do, graph each line and then graph the ordered pair as well. All right, we're going to do a little more practice graphing. We also want to tell how many solutions it has. So sometimes there is one solution, and all the examples that we just had was one solution. And what that means is there's one point of intersection, one point in common. But there could be infinitely many solutions. If they happen to be the same line, there could be a whole lot of points in common, and there could be no solutions. If there are no points in common. So we have some options here, and we want to choose the best one. So I'm going to go ahead and graph this equation because it's already in slope-intercept form. So I'm going to start with my y-intercept at 1. And then my slope is negative 3 over 4. So I just always put my negative with the top number. So then I can go down 3 and to the right 4. So down 1, 2, 3, and to the right 1, 2, 3, 4. All right. And then this other equation, a little more tricky. I need to solve for y. 6x plus 8y equals 8. I'm going to go ahead and move the 6x to the other side. So we get 8y equals negative 6x and a positive 8. And then I can divide by 8. and I get 6/8 is a fraction and it reduces. I can divide top and bottom by 2. So that'd be -3/4x. And 8 divided by 8 is 1. So here is my second equation. So, oh, look it has a y-intercept of 1 as well. And it has a slope of -3/4. Oh, it is the same line. It is graphed right on top of itself. How many points in common do they have? They are the same line. There are an infinite number of points that are overlapping here. So there are infinitely many solutions. Infinitely many solutions. All right, so when they are the same line, we have infinitely many solutions. All right, I'm going to go ahead again and graph this easy one that's already in slope-intercept form. So I get y equals 2x plus 3, so it has a y-intercept of 3. And in this case, the slope is down 2 and right 1. So down 2, right 1. And the second equation needs some work. So I need to isolate the y. I'm going to go ahead and move the 4x term to the other side. So I get 2y equals -4x and a -6. And then I'm going to divide every single term by 2. So I get y equals -2x, minus 3. -6 divided by 2 is -3. All right, let's look at this equation. It has a y-intercept at -3. And this slope is -2/1, down 2, right 1. All right. So what kind of lines are these? Whoops. Boy, that's horrible. They don't look, they are supposed to be parallel. They don't look parallel, do they? Because my ruler was all wonkadoodle. All right. Good enough for government work. Okay. These lines have the same slope. Here we have a slope of -2, and here we have a slope of -2. Same slope with different y-intercepts. These are parallel lines. These are parallel lines. So how many points of intersection are there? None. They're never going to cross. They're parallel. So we get no solution. All right. So be very careful looking out for parallel lines. No solutions because there are no intersection points. And just really fast before we finish up, I want to remind you that the line x equals 5 is a vertical line. Okay, so if we had to graph that, we would go to 5 on the x-axis, and you'd click a point, and then you'd click a point above it or below it, and that will get you a vertical line. If x equals a number is a vertical line, y equals a number must be a horizontal line. All right, so pay attention. So you would go to the y-axis, you'd go to -3, and then you'd click a point to the right or to the left, and that'll get you your horizontal line through -3 on the y-axis. All right, ladies and gentlemen, have fun with E.2. Again, make sure you're clicking the equation first, the colored equation first, and then trying to graph that equation. All right, folks, have a great day.